Okay guys, so welcome back again another video. So here we are going to talk about the Acyloin condensation, one of the major reactions in organic chemistry. So if you are following the retrosynthesis course, I'm pretty sure you are going to meet this reaction. Now which we are talking about is a compound like this. Okay, we can convert it into a carbonyl group with these reagents. So we are going to talk about the mechanism what happening here, right? The one thing you need to understand or you need to memorize is these reagents. Most of the questions will be based on these reagents, like you will need to identify the reagents for certain reactions likewise, and also you need to understand the mechanisms. If there are there can be questions based on mechanism, right? So mechanism is not as complicated one, it's a pretty much easy, just you need to understand the process, right? Just understand the process. Now another important thing with the mechanism is this involves radicals, right? The initiating step of this mechanism involves the radicals. So first what happens is, let's say we have a compound like this, right? So there are sodium radicals. These sodium radicals are the ones who's going to initiate our reaction, right? So what happens is this radical will go and form here. Due to this formation, this electron pair will go to form with oxygen, right? So now we will have our product light. These two bonds have been removed to oxygen, and we have oxygen here and here are here. Now there's a radical here which is donated from this sodium. Now sodium has removed its electron, right? It has left its electron, so sodium is there as a positive charge. So another thing you need to be very careful about is the arrows. So let me draw it like carefully. Here you can see this arrow is a half arrow because I am representing a particle, right? You get it. So here I am drawing the arrow as a full arrow because it's not a radical, it's an electron pair. So I am here representing the movement of a fully electron pair. Here I am representing the movement of a radical. These are the very small points which most of the people, like most of the guys, are getting confused of, right? Due to this, if you draw a full arrow here, it will lead to a reduction of marks. So be very careful about this. So these are very simple reactions, simple mechanisms, so they are easy to understand, but there are some small details which can lead you to loss of marks. So here now we have this compound. You know, when the reaction is happening, the system contains lots of molecules. So this can happen with another molecule. So let's have another molecule here. This is the same, right? The same molecule. Now you can see these both of these molecules are radicals, so these two can combine together. So we will have the product like this. Let me draw it. Like this. Here we have the product from combining these two molecules. Now what happens is, you can see there's a lone pair here. This lone pair will come back to form the pi bond. Now when the pi bond is forming, you will see this carbon is getting destabilized, right? So it has to leave one of its bonds. So this bond will be removed on its own. So we will have a product like this. Sorry. And we have R and we have O. And again, the same thing can happen over here too, right? So this lone pair can form the pi bonds again. So you will have the final product as a dicarbonyl compound like this. Okay, this is the product which we have obtained. Now you know that there are sodium radicals, right? There are sodium radicals in your system. These sodium radicals can facilitate the same reaction which has done over here, right? The same reaction is happening. So this radical is going to be donated into this particular position, is going to be donated into this particular position, and due to this position, this lone pair will move to here and this lone pair will move to here. So we have our product like this. Now we have two radicals here. Now you can see that these two radicals, right here you have two radicals here, two lone electrons in these places. So these two can come together to form a pi bond between these two carbons. We have our structure like this. Now by adding a H plus, or basically like normally acid, right, you can obtain this one diol. This is a diol. Now this can undergo the tautomerism to form our desired product. So this is our desired product, right? This is our desired product. You can see here. This is the desired product. This is a result of this tautomerism. This is a tautomerism. Okay. I hope you know about these things. So this is the pretty much the reaction, right? This is the pretty much the mechanism. I hope it's not a big deal, right? The first thing you need to understand is these radicals, right? This is the first initiation step, and then these steps are moving towards to form this pi bond between the carbons. That's the important thing, and the loss of these OR groups. So like draw this mechanism 3 to 4 times, then you will get the idea. It's not a big deal. Like if you have any questions, feel free to comment below. I will try my best. So in next video we will do the retrosynthesis, our next retrosynthesis video, which will be based on this particular reaction. So I hope you get the I hope you have a good day and all the best for your exams.